Section 1.5, problem solving using algebraic models. Example 1, which can be found in your textbook on page 33. We have the bullet train that runs between two Japanese cities at a distance of 550 kilometers apart. When it makes no stops, it takes 2 hours and 15 minutes to make the trip. What is the average speed of the bullet train? So we're going to use the distance formula. Distance is equal to rate times time. So we're going to use the formula D equals R times T. If we look at our word problem, it tells us the distance between the two cities is 550 kilometers. The rate is what we're looking for. We're looking for the average speed of the bullet train, so we'll leave R as R. And the time is given as 2 hours and 15 minutes. So we'll convert that to a decimal, which will be 2.25. 15 minutes is 0.25 of an hour. So 15 over 60 will be 0.25, so 2.25. So here we'll divide both sides of the equation by 2.25. And that tells me that the train is traveling at a rate of 244 kilometers per hour. In our next example, on 8/15/1995, the Concorde flew 35,035 miles from New York City to New York City in 31 hours, 27 minutes. What was the average speed of the Concorde? So using our same formula, D equals R times T. We know our distance is 35,035 miles, so we'll substitute that for D. We don't know its average rate of speed. We're looking for R. And the time is given as 31 hours, 27 minutes. So that converts to 31.45. Then we'll divide both sides by 31.45. And that tells me that the rate of speed was 1,114 miles per hour. Example 2, which can be found on page 34 of your textbook. We have a water-saving faucet has a flow rate of at most 9.6 cubic inches per second. To test whether your faucet meets the standard, you time how long it takes the faucet to fill a 470 cubic inch pot, obtaining a time of 35 seconds. Find your faucet's flow rate. Does it meet the standard for water conservation? So we're going to use the formula that volume is equal to the flow rate times the time to fill the pot. So the volume of the pot is equal to the flow rate of the faucet times the time that it takes to fill the pot. So V equals R times T. So the volume was 470. The rate, we don't know. And the time was 35 seconds. So if we divide 470 by 35, that's going to give us a rate of 13.4 cubic inches per second. Okay, does this meet the standard for water conservation? So it tells us in the first sentence that a water-saving faucet has a flow rate of at most 9.6 cubic inches per second. So we can see that it does not meet the standard. 13.4 is higher than 9.6. So it does not meet the standard as a safe water conserving faucet. Example B, a shower head advertises a maximum flow rate of 2.5 gallons per minute. Find the flow rate if it fills a 22-gallon bathtub at 9.5 minutes. Is this within the advertised limit? We'll use volume again equals the rate times the time. So the volume is 22 gallons. We don't know the rate. We do know that the time takes 9.5 minutes. So if we divide 22 by 9.5, that's going to give us 2.3 gallons per minute. And it says that we should be looking for a maximum flow rate of 2.5 gallons per minute. So 2.3 is less than that. So this would be, yes, it is within the advertised limit. Okay, in example 3, you own a lawn care business and you want to know how much money you spend on gasoline to travel to out-of-town clients. In a typical week, you drive 600 miles in total and you use 40 gallons of gasoline in total. The price of gasoline is $1.25 per gallon, and your truck's fuel efficiency is 21 miles per gallon on the highway. That would be for out of town, and 13 miles per gallon locally. So in order to figure this out, we need to write our formula. So we're going to start with the total miles we travel each week. So we have our total miles. And that's going to be equal to our fuel efficiency on the highway So we'll say highway fuel efficiency times the amount of gas plus the local fuel efficiency times that amount of gas. Okay, so our highway fuel efficiency times the gas plus the local fuel efficiency times the amount of gas is going to be equal to our total miles. So we'll need to substitute what we know. The total miles that we're traveling each week is 600. Our highway fuel efficiency is 21 miles per gallon. So we'll use 21 times X. We don't know how many gallons we're using, plus our local fuel efficiency, which is 13 miles per gallon. And for this, we'll use the total amount of miles, or I'm sorry, total amount of gallons of gas, which is 40, minus X. Okay, so if X, we'll have X represent the highway gallons, so we'll take the 40 total gallons minus the highway gallons. That'll leave us the local gallons. So here we have 600 is equal to 21X plus 520 minus 13X, and we'll combine our like terms, which will give us 80 equals 8X. Divide by 8, and X will be equal to 10. So that's 10 gallons. We're going to multiply that 10 by the $1.25 that it costs for gas. And that tells me that I'm spending $12.50 to travel to my out-of-town clients. In example B, you drove 280 miles using 15 gallons of gas that cost you $1.15 per gallon. If you get 24 miles per gallon on the highway and 16 miles per gallon in the city, how much did you spend for fuel for highway driving and how much for city driving? So here we're going to take the same type of equation as the last example. We have a total of 280 miles that we travel. Okay, and that's going to be equal to the highway plus the city. So we're going to take the 24 miles per gallon for the highway, and we're going to add the 16 miles per gallon in the city. Again, we're going to multiply this by the 15 gallons total minus X, which represents the highway. So we have 280, which equals 24X plus 240 minus 16X. We'll combine our like terms. This will give us 40 equals 8X. And X will be equal to 5. So that's 5 gallons for the highway. So for the highway, we'll take that 5 gallons and we'll multiply that by the cost of $1.15. And that tells me that it's costing me $5.75 for the highway. And then for the city, we're going to use the 15 gallons of gas minus the 5 gallons of gas. So 15 was the total, 5 for the highway. So 15 minus 5 equals 10 gallons for the city. So that gives me 10 times the $1.15 that it cost me to buy the gas, and that gives me $11.50 for the city. Okay, example 4, we have the Central Pacific Company, which averaged 8.75 miles of track per month. The Union Pacific Company, which averaged 20 miles of track per month. The photo in your textbook shows the two companies meeting at a city in Utah as the 1,590 miles of track were completed. When was the photo taken and how many miles of track did each company build? So you're probably going to want to refer to your textbook so you can look at the detailed information provided in the photo. We're going to come up with our equation, which is going to be the total miles of track which is going to be equal to what each company was able to do, right? How many miles per month times the number of months that it took for each company. So for the Central Pacific Company, we're going to look at their miles per month times the number of months. And we're going to add our other company, the Union Pacific Company. Same information, the miles that they covered per month times the number of months. So we'll fill in this information. So our total miles was 1,590. For Central For the Central Pacific Company, the miles per month was 8.75. The number of months we don't know, so that'll be X. For Union Pacific, the miles per month was 20. And the number of months will be the number of months for the Central Pacific Company minus 24. Now, the 24 comes from the photo. When you look at the picture, it says that the Union Pacific Company started 24 months after the Union Pacific Company started. So we're going to take the number of months that the Central Pacific had and subtract the 24 months later that the Union Pacific started. So then once we calculate what X is equal to here by combining like terms, distributing, we'll have our value of X. And it looks like X is going to be equal to 72. So this will be the amount of months for the Central Pacific. So we're trying to figure out when was the photo taken that you see in your textbook and how many miles of track did each company build. So for Central, we're going to take the 72 months and we'll multiply that by 8.75, which was given as the average miles per track that the Central Pacific was able to lay, and that will give us 630 miles for Central. And then for Union, we'll take the 72 for Central, subtract 24, which is how many months later the Union Company started. And we know that they averaged 20 miles of track per month, so we'll multiply that by 20. And that'll give us 960 miles for the Union Company. So that answers how much track each company was responsible for or was able to complete. And then when was the photo taken in the picture there? So it says that the process was started in the year 1863. And if it took 72 months, that's 72 divided by 12, which would be 6 years. So if we add 6 years to that, we could say that the process or the year that the track was completed was in 1869.